Hey, Algebra 2. Today we're going to do solve log equations 4.6. This is the beginning of the end, the last section of chapter 4. Today we're going to focus on solving log equations where there's log on both sides. And tomorrow we'll focus on changing the base in order to solve a missing exponent or something along those lines. So you could pause to write this equation down. But and if you don't see it, it's log base 4, 2x plus 6 equals log base 4, 3x plus 3. Now, kind of like those questions from before, this only works if the logs are exactly the same. So if the logs are exactly the same, that's good. Because what we're allowed to do when the logs are exactly the same is that since these both are on the same side and they're both on the equal sign, I'm allowed to cross this off or cancel it. And how do I actually cancel it? Let's just talk about the actual action. All you need to know that you have to cancel it. But it's like I'm slipping a little power of 4, base of 4. And remember, base of 4 to the power of log base 4 cancels out to 1. So putting a 4 on both sides would cancel this out. So this only really works if you are have a log on of the same number on both sides. So you got to make sure they're the same number. Honestly, I'm not going to trick you and put a different number and say, haha, you couldn't actually solve it. But so now, because the logs are completely gone, we're just left with 2x plus 6 equals 3x plus 3. And look at this. This is an Algebra 1 question. So let's subtract 2x on both sides. And because we're Algebra 2, I'm going to be a little confident, and I'm going to subtract 3 on both sides at the same time. So I'm going to cross out these 3's, and I'm going to cross out this 2x. So 6 minus 3 is 3. 3x minus 2x is x. So we believe one of our answers is x equals 3. Notice I use the verbiage believe. So in log equations, there's a rule about logs. And it never had come up, but let's check how that rule looks. All right, just remember what a log is. So let's say if I said log base 2 to the, let's say 8 equals 3. Now remember, if I wanted to solve this or rewrite it in exponential form, I take the base of the log and slip it over, and it becomes the base of the exponent. So it's 8 equals 2 to the third power. And yeah, that checks out. Okay. Now, the special thing about log, so this number here should be the answer to something to the exponent. So this number here inside the log should be the answer to x to some y exponent. Now, this rule hasn't come up before, but let's say if log base 2, negative 1. Let's try to figure out what that is. So I take my 2 and move it down here. Negative 1 equals 2 to the x power. Now, here's my issue. No matter how many 2's that I multiply into it, no matter if I cut it in half, doesn't matter if I double it, triple it, quadruple it, I can never get negative 1. That can never happen. So I have the big issue here. Wait a second. This is impossible. This right here is impossible. And because this is impossible, this is considered an extraneous solution. So the rule is you can never have a negative inside the log. You can never have a negative inside the log. So this happens to be impossible. And we're not allowed to have a negative in the log. Mr. Tobel, how does that apply to today's lesson? Well, before we could say 3 is an answer, we're going to have to plug it into both of these sides and see if they become a negative. Actually, I'm sorry, you only have to plug it to one of them. And you're going to choose either one to see if it becomes a negative. If inside the parentheses, when you plug in your x, it becomes a negative, it is called an extraneous solution, and thus is impossible. So let's try it. I'm going to plug it into the left one. You could choose which one you do it, but you only need to plug it into one. Because you just set them equal to each other, they're going to end up being the same thing anyway. So 2 to the third power plus 6, that is 6 plus 6, that equals 12. And I'll just go to check my work by doing the other one. 3 to the third power plus 3. 3 times 3 is 9 plus 3, which is equal to 12. So you notice they both equal, and very important, a positive 12. So since they both equal a positive 12, this is a solution. So we put a big check mark right there, okay? So this is a solution. We are happy. So I'm going to do 2 more examples. One is going to be with an extraneous solution. All right, with editing magic, we're on the next one already. You could pause to write it down. Log base 6, 2x minus 10 equals log base 6, 4x minus 14. So I'll write down the steps in the post, but let's just talk about the steps. Step 1, if the logs are the same, cancel them out. So this is a log base 6, this is a log base 6. We're allowed to cancel it out. So now we're at 2x minus 10 equals 4x minus 14. Okay, second step, we're going to solve for x. So we're going to solve for x. So we got a plus 14 over here, plus 14. I'm in Algebra 2, so I'm a little cocky. So I'm just going to do it all at the same time. Cross out this 14. Cross out this negative 2x. So here I got 4 equals 2x. 4 minus 2 is 2x. Then we're going to divide by 2, divided by 2. 2 equals x. So I finish my second step. Is a solve for x. Now I'm going to do my third step, which is plug in and check for extraneous solution. So the extraneous solution, why we call it extraneous, is because it stretched the rules of what's allowed. So technically it would be a solution, but only in an imaginary situation. So I'll plug it into the first one. Again, it doesn't matter which one you plug it in. You should get the same solution. And if you want to check your work, you could just technically plug into both to make sure you got the right answer. But 2 times 2 minus 10, 4 minus 10, negative 6. Uh-oh. This is negative. Because this is negative and causes a negative in this log, what the issue is that 2 is not an applicable answer. 2 is what we would consider an imaginary answer. So negative 6 over here shows us that 2 is an imaginary answer. So your final answer should be no solution. There is no numbers you could put in that makes it equal that is not imaginary or results in an imaginary number. Okay? So when you get an extraneous solution, you got to put no solution. 1 or 2 more. Okay? So let's do our next one. Pause if you need to write it. Log base 3 of negative 3x plus 1 equals log base 3 x plus 13. All right, first we're going to see if we can cancel out the logs. Hey, they're the same number. So step 1, cancel out the logs, it's a go. So now we're just going to rewrite it. X plus 13. All right, our next thing is solve for x. Negative 3 is smaller than positive 1, so I'm going to add 3x here. And then I don't want the 13 to be here because all my x's are here. So I'm going to subtract 13 here. If you subtracted 1x and minus a 1, that's totally fine. You're allowed to do that. Just keep in mind that would have been a negative 4 over here. So this cancels out, and this cancels out. So 1 minus 13. So you're on floor 1 and you're going 13 down. So you're at negative 12. And then x plus 3x, this is a 1, remember, if you don't see a number, so that's 4x. Divided by 4, divided by 4, x equals negative 3. Now, here's a very important the reason I made this example up. A negative could be your answer. Remember, it's not the x that's the problem if it's negative or positive. It's when you plug it in, if it's negative or positive, we're allowed to do it. So the third step is to check. I'm going to plug it into the left one. Negative 3 times the negative 3 plus 1. 9 plus 1, because double negative becomes positive. That equals 10. 10 is a positive number. So even though x was negative, the check was positive. As long as the check is positive, we are happy. So negative 3 is a solution. Okay? So negative 3 is a solution. So remember, and this is why I picked this example in particular, the x could be any number. It could be a billion or negative billion. What matters is if the check is positive. If positive, the number is the answer. If negative, it's a no solution. All right, I'll post the homework. Most likely we'll do a Zoom to go over the questions if you wish. All right, have a wonderful day.